The Andromeda Galaxy, also known as M31, is the largest spiral galaxy in our local group and the nearest large neighbor of the Milky Way. Its history began more than 10 billion years ago, shortly after the universe had experienced its first billion years of existence. At an early stage of formation, in a chaotic and dense outer space, condensation of matter under the influence of gravity began from a huge cloud of hydrogen and helium. A protogalaxy formed from this cloud, which later turned into Andromeda. For billions of years, Andromeda has collided and merged with other, smaller galaxies, absorbing their stars, gas, and dark matter, gradually increasing its mass and developing the structure of spiral arms. Such collisions played an important role in its evolution. Each act of fusion caused bursts of star formation, forming bright star clusters and saturating the galaxy with new stellar matter. One of the largest collisions apparently occurred about 8 billion years ago, when Andromeda swallowed up a dwarf galaxy, which caused a strong disturbance in its structure and a change in the direction of rotation. This collision probably caused the formation of a massive bulge, a dense stellar core in the center of the galaxy. Over the next billions of years, Andromeda continued to attract and assimilate dwarf moons, which can still be observed today. In its halo, in the form of long stellar streams, traces of these ancient absorption remained. Also, a supermassive black hole, with a mass exceeding 100 million solar masses, has settled in the center of the galaxy, and which actively interacts with the surrounding matter. Andromeda contains about 1 trillion stars, about twice as many as in the Milky Way. Its spiral arms, riddled with nebulae, young star clusters, and supernova remnants, demonstrate the dynamics of star formation and rotation. It is surrounded by more than 24 satellite galaxies, among which are known M32 and M110 dwarf elliptical galaxies located in the immediate vicinity of the main disk. Andromeda and the Milky Way are currently about 2.5 million light-years apart, but they are moving towards each other at a speed of more than 100 kilometers per second. According to the models, they will collide in about 4 billion years. The stars of the Andromeda Galaxy are very diverse. As in the Milky Way, Andromeda can be found young, hot blue stars in spiral arms. They form in dense clouds of gas and shine very brightly, but they do not live long, several million years. Yellow dwarfs like our Sun are more stable, medium-sized stars with possible habitable planets. Red dwarfs are the most numerous and long-lived stars in the galaxy. Many of them may have planets, including potentially habitable ones. Giants and supergiants are stars completing their life cycle. They can be seen as very bright objects, especially in the infrared and ultraviolet range. White dwarfs, neutron stars, and black holes are the remnants of stars that have ended their existence. Some of them are the result of supernova outbreaks. At the center of the Andromeda Galaxy is a supermassive black hole with a mass exceeding 100 million solar masses. It is surrounded by a dense stellar dense cap, or bulge, consisting of old red and yellow stars. This area is relatively calm, but it could have been active in the past, perhaps even had quasi-stellar activity. As for the planets, we cannot yet directly observe exoplanets in Andromeda, in the same way as in our galaxy due to the huge distance. However, based on the model of star formation and the analysis of the spectra of stars, it is highly likely that there are billions of planetary systems in the Andromeda Galaxy. Many of them formed in the same way as the solar system, from gas and dust disks around young stars. There are probably Earth-type exoplanets, especially around yellow and red dwarfs, where conditions could be stable for billions of years. Some systems may have super-Earths, hot Jupiters, ice giants, and other types of planets discovered in our galaxy. Andromeda also has many star clusters, both scattered, where the stars are young, and globular, where there are ancient stars up to 13 billion years old. Globular clusters may contain systems with exoplanets, although the environment there is generally more hostile due to the density of stars. Thus, despite the huge distance, scientists confidently assume that planetary systems developed in the Andromeda Galaxy, similar to those we observe in the Milky Way. This makes Andromeda not only an interesting object to observe, but also a potential mirror of our galactic history. Perhaps even with other life forms,